Okay, so got a little substitution in here. Mrs. B is working on some stuff right now, so I'll be doing at least part of the notes. If she gets done, she'll finish, but we'll just plan on me doing the rest of them, or rest of them for this section of notes, not all of them. So getting started, congruent triangles. So we'll mark this A, B, C, and then this one D, E, F. So to be congruent, they need each side to be congruent with one on the other triangle, and then all of the angles to also be congruent. So go ahead and mark those up. She is a better artist than I am. So on the bright side, know that London has a possible future for any artistic abilities, because it will not be coming from me. So these need 3 congruent sides, 3 congruent angles. So nothing new there. Hopefully that you're figuring out. Congruent statement is, so if we have triangle ABC is congruent, and then it needs to match up. So A matches up with D, F matches up with B, and then E matches up with C. So they won't necessarily go in alphabetical order. So you just need to match it up and take note of that. So sometimes the problems will try to trick you by just thinking it'd go alphabetically. But like in this scenario, it does not. So just be careful of that. And then corresponding parts. So looking back to the original one again. So line AC, if you look at what matches up on the triangle, and you can even look within the statement here, if you have AC, that would obviously have to match up with line DE. Or if you look at an angle, angle DEF is congruent to angle ACB.
Sorry, I missed that.
So you could do it that way for corresponding parts. Parallel lines. So this is what we did last chapter. You have 2 parallel lines cut by a transversal. So any of those relationships that we used previously will come into play here as well. So some to watch out for would be alternate interior, corresponding, obviously vertical, but that's already written. So just remember, like, corresponding would be marked in these blue ones, with alternate interior being marked in the red. So just something to watch out for there. Vertical angles. Oh, that line sucked. So vertical angles, we'll try this line better, are angles that are across from each other. So for instance, blue matches up with blue, and yellow matches up with yellow, and vertical angles are congruent. Common sides, so this is a new one that you know, but you don't know that you know it yet. So if you had a triangle like this, so let's say this is A, B, C, and D. So if you have let's say triangle ABC here, and then triangle BCD, you should notice that both of them have BC in it. So line BC is congruent to line BC. Seems simple, which it is, but you still have to write it. Whenever we get to proofs, this is the proof, or this is the property that we never got to use before. So this is the reflexive property. Okay, so now we're going to look at pictures and mark them. So looking at number one, one thing that should hopefully jump out is the vertical angles. So those two are congruent because of being vertical, so they're across from each other. Now you may think, oh, B and E look the same and A and D look the same. They probably are, but because there are no parallel lines marked, you can't mark them. So it would be angle ACB is congruent to DCE.
Okay.
And the reason for those would not be alternate interior, would be vertical. And again, as you can guess, proofs are coming next class, so get in the habit of trying to be able to pick out something with a reason, because you're going to have to next class. You might as well start now so you're a little bit ahead of the game. So number two has the exact same vertical angle. So angle ACB is congruent to angle DCE, and those are vertical. And now B is on the opposite side of E, so those would be alternate interior, and the same thing for A and D. So don't typically write your angles like this, but for the sake of time, we're going to write them like this. So angle B is congruent to angle E, and those are alternate interior. Angle A is congruent to angle D, alternate interior. So remember, on a test, you need to write them with 3 letters, but on these notes, because these notes are going to be, well, they are quite long, we're just going to do single letters so we can move on quickly. Okay, 3, nothing is marked, so the only thing you can say is congruent is HF, which is congruent to itself. So HF is congruent to HF, and the reason being would be reflexive. If you put common side, that would also be accepted, but I would just get in the habit of using the property, because you're going to, again, that's what it's going to be expected to be known on the proofs. Okay, and then to the bottom ones. So number 4, you only have these, so you would say obviously that line LM is congruent to line MN. So if that seems too easy, that's because it is. So as we learned last class, that if you have isosceles sides, that means you have isosceles angles. So you could say that angle MLN is congruent to angle MNL, and you could say the reason being isosceles triangle. So because you know that's an isosceles triangle, those are isosceles angles. Okay, number 5 is a little bit trickier. So we have two parallel lines. So imagine, so you can use these two parallel lines at once, or you can use the red parallel lines at once. You can't use them both at the same time. So if you were only talking about the green lines, you could say that Q matches up to that, Y, because those are corresponding. And then you could also have if you would turn your paper or look at it the other way, that the purple could also be marked for the same reason, that those are also corresponding. So because it's what's happening is just how we drew that transversal earlier, this QSU is acting as the transversal in this situation. So a little bit confusing, but just try to remember that those are corresponding both. You could not have R and T being corresponding because that would involve both sets of parallel lines. So you could only have it where one set of lines is used at once. So that's why we can't mark those two. Okay, and going on to number 6. So obviously those sides are marked. So line WX is congruent to line ZX. Another thing you could mark is the center. So line XY is congruent to line XY. Again, because it's reflexive. So because it's the same line, you could use that one twice there. So on these, so this is what's leading up to being able to use the stuff in the future, but try to get in the habit of being able to see that reflexive matches up. Ones like 5 are pretty common as well. So just try to remember those because they do come up quite frequently throughout the homework and on the tests and quiz.
Hi, it's Mrs. Portrading now. So I am back. I was just putting London to sleep, so Mr. B did the first part for me. But we're looking at congruence now. So there are certain ways you can show congruence with triangles. Our first one here is side-side congruence. So basically, if you have two triangles, so we're going to say triangles are congruent if they have 3 congruent sides. Okay, so I'm going to draw an example for each of these, and I would copy that down as well. So if I have ABC here and maybe DEF. And I'm trying to make these look congruent, but they may not be perfect. So you want to look at what sides are matched up here, okay? So I'm going to say that AB is congruent to DE, and then EF is congruent to BC, and CA is congruent to FD, okay? So there we have all three sides are shown that they're congruent. Sometimes this information is given to you. Sometimes you might have to look a little further before you can draw those symbols and show that. So if I have that, I could say my congruence statement, it's going to ask for that. I'll say triangle ABC is congruent to triangle DEF. And just like when we did angles, make sure you're putting this triangle symbol in front of there as part of your statement. And if I needed to say why, okay, well, side-side congruence is here, so I would just say SSS congruence was my reason. Okay? All right, your next one is angle, side, angle. So for this one, it means that triangles are congruent if they have two angles and an included, or sorry, two congruent angles and an included congruent side. And just to reiterate, I think this was stated earlier, but an included side is the side between the two angles. And I'll show you what I mean here in a second. All right, so for here, I'm going to draw LMN. And XYZ. Okay, so let's say they give us that LM is congruent to XY, so I could mark that. And think when we get to proofs, you want to think when they tell you that information, I go ahead and I mark it on my triangles or my shapes when they tell it, so I can kind of look and quickly see. Maybe they say LMN, so this angle is congruent to XYZ, so this angle. And then MLN, so here, is congruent to YXZ, so here. All right, so that means for that we have an angle that's congruent, another angle that's congruent, and then an included side. Remember what I meant by that is it's in between the two angles. So we have that ML is congruent to YX. So that is angle, side, angle. All right, so for my congruence statement, I would say that triangle ABC is congruent to triangle. And then when you do, oops, not ABC, just kidding. Triangle LMN is congruent to triangle, and then I want to make sure these letters that are congruent match up. So like L matches up with X. Those are the two that are congruent to each other. And then M to N, N to Z. So I have to make sure I write them in that order. So with L was first there, so I should have X, then was M, so I should have Y, then N, so I should have Z. Okay, for my reason for this, when we get to proofs, I would say ASA, so angle, side, angle, congruence. All right, next one here is side, angle, side congruence. So triangles are congruent if they have two congruent sides and an included congruent angle, which, similar to included side, this will be the angle between the two sides. Alright, I'm gonna draw my triangles here. Oops. So I'm gonna make that NOP, and this corner one up here is gonna be a right angle. And then I'm gonna have SRQ, and that's our right angle. Okay, so if they show us that, or they show or tell us, remember if they tell you in a proof, then you have to go in and mark it. So segment NO is congruent to QR. I know I did not make those look very congruent, but let's just pretend. And then OP is congruent to SR. So here they didn't actually tell us that our angles are congruent, but we know they are both 90 because that's just what a right angle shows us there. That symbol shows us. So now I can go in and write my congruent statement because I have enough. I have a side, an angle, and a side that match up, side, angle, side here. So I would say triangle NOP is congruent to triangle, and we have to remember we have to match up each one. So I can't start with S because N and O was my first single congruent, so like there. So I need to start with Q. So congruent to Q, R, S. And my reasoning when we get to proofs would be side, angle, side, congruence. Okay, our next one here is angle, angle, side. So here triangles are congruent if they have two congruent consecutive angles, and that just means like right beside each other, right in a row, and a congruent adjacent side. Remember, adjacent means beside. Okay, so for here, I'm going to draw ABC. And FED. Okay, so if they say that, let's do BAC is congruent, so that's right here, is congruent to EDF, so right here. Then maybe they say that DEF there is congruent to ABC here. And then lastly, side AC is congruent to side FD. All right, so here we have, so angle, angle, side. So two consecutive angles, meaning this angle and this angle come right beside each other, right in a row. And then adjacent is going to be beside. So I could have, if they'd give me this one, that would work. Or if they'd give me that side and this other side, okay? So you could have went either direction with that, but. All right, so from there, that gives us enough info that we can write our congruent statement. So I would say triangle ABC is congruent to triangle. Remember, I have to make sure these match up. So in this case, it's DEF. And then my reasoning would be AAS, so angle, angle, side, congruence. All right, and last for this little section here is hypotenuse leg congruence. So this is going to be dealing with a right triangle. All right, so I'm going to say right or 90-degree triangles are congruent if they have a congruent hypotenuse, which if you don't remember that from, I don't know, 8th grade or something, that is the side across from the 90-degree angle, or it's also the biggest side, and they also need one congruent side. Okay, so let's draw this here. Move that LM in. X, Y, Z. Not a very good right angle, but okay. So now I can look at this and see, so maybe they say that XY is congruent to side MN and YZ is congruent to side LM. All right, so the reason we can use this one now, oh, you know what? I need a hypotenuse. Whoops, there we go. Okay, so XY is congruent to MN, and then they're going to say LN is congruent to XZ. So our hypotenuse here is this side and this one, because they are across from the right angle. Okay? All right, so we know already that these angles are congruent because they're both 90. So that's why they don't have to tell us that or spell that out. And then it says, so we need right angles are congruent if they have a hypotenuse, congruent hypotenuse, which we have that here, and one congruent side. I forgot the one there. All right, so we have enough there that we can go ahead and write our congruent statement. So for this, I would say triangle LMN is congruent to triangle. And then again, we have to make sure that matches up. So I actually have to start with Z instead of X because LM and YZ are the ones that are kind of off there. MN is congruent to XY, so I have to match that up. So it would be Z, then to our right angle, Y, oops, out to X. Okay, and then just kind of make sure those match up. So X and N have the congruent side on there. All right, my reason then would be, on these, I would just, you can shorten a little bit, but hypotenuse, leg, congruence. Okay, on your next section there, it's steps to determine congruence. So when we start getting into proofs next lesson, these are kind of some things you want to look for when they're given those images. We're going to be given some images down here that we'll play with, and then when we get into proofs there. So you can look for congruent angles, okay? So maybe they tell you them, or maybe you have a way to prove them, like maybe there were vertical angles that are congruent or alternate interior, okay? I believe this should say look for congruent sides. Make that say sides. Use side, 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 angle, side, angle, side, angle, side, angle, angle, side, or hypotenuse leg congruence. So that's what we just looked at. Or use congruent parts of congruent triangle, corresponding parts, of congruent triangles are congruent. And I don't know, we haven't actually gotten to that yet, so we'll do that next lesson, so don't worry about that just yet. But, so for these next questions, you're going to determine if the following triangle pairs are congruent. So, are the two triangles there congruent? And if so, how? And we have to write that congruent statement. So, the part we did earlier, like triangle ABC is congruent to triangle XYZ. So, starting off there with 7, they've given us some marked parts here. So, we want to just see, is that enough? So I have a side here congruent to side there, and I have an angle congruent, and then another side. Okay, so that you want to think, well, side, and I kind of go in a row when I look at this. So side, angle, side. Well, is that up here? Yes, it's right there. So that means those are congruent, so I have to write my statement. So I would say triangle QYT is congruent to triangle. And remember, I can't start with P because that goes with the T. I have to start with C that goes with Q. So C, K, P. All right, it says also, so I wrote the congruent statement, but I need how. So my how would be side, angle, side, congruence. All right, 8. So I have AD is congruent to BC, DC is congruent to AB, and then another thing is they share this middle side, okay? So that's what we had earlier when we looked at the common side. That's a common side, meaning it's going to be congruent, all right? They share that. So now I have 3 congruent sides, which is side, side, side. All right, so I would say, I forgot to write yes over on this one. So again, I would say yes, they are congruent. All right, now write the statement. So I want you to pause here and see if you can write the statement and write out your reason as well. Okay, you should have gotten triangle ADC is congruent to triangle CBA. And your reason would be side, 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 congruence. Actually, you know what? I'm going to start writing these out just to make sure we have them memorized, okay? All right, 9. So 9 is a little bit different because they do give us 2 sides, okay? But when we have to go back and think, look for congruent angles, all right? They don't show us any congruent angles here, but there is a set because there's a set of vertical angles. So BCA right here is congruent to DCE here because they're vertical angles. So now I have side, angle, side. Okay. So I would write my congruent statement. So yes, they're congruent. I would write my congruent statement as triangle BCA is congruent to triangle, and remember, we need to make sure here that we start with D and not E. So D, C, E. And our reason would be side, angle, side. Excuse me. All right, number 10. So here we have a set of congruent sides there, right there, and an angle. So I want you to take a minute, pause here, and see if you can, actually let's go through and do 10, 11, and 12, right? Yes or no. Make sure you are using pencil, 100% on this because you might mess up, and that's okay, but we're going to fix it. So pencil, do 10, 11, and 12. See if you can determine if they're congruent. If so, write the statement and tell why. So pause here. Okay, if you pause, we should be checking now. So number 10 is actually a little bit tricky because it is not congruent. Okay, all we have here, we have side, side, angle. Okay, well, that it actually isn't one because the order does matter on the congruence, like angle, side, angle. We can't flip them around and be wherever. They have to be kind of in order consecutively. Okay, so this one is not congruent. So no. All right, 11 was congruent. So yes. And if you got it correct, you should have said that triangle ABC is congruent to triangle DEF. All right, and the reason would be angle, side, angle, because I have angle here, then side, then another angle set. So remember, order matters. All right, 12 also should have had yes. Your statement would be triangle JMK. This one was a little confusing looking because it sort of looks like there's 3 triangles, but they're just overlapping. And then triangle, remember I start with J here, so I should start with L. Then go to K to match up with M, and then out to M, sorry. So we actually didn't use N at all here, it was just kind of the cross point. All right, and our reason, so we have a side here and here, and we have an angle here, and this may have been a tricky one for you, but this line here is also a shared, it's a common side, so they share that, so I have side, angle, side. All right, 13, 14, 15, so let's do the same thing there, except let's do, just pick one in your group and do that. If you have a group of 4, then double up on one of them. Actually, if you have a group of 4, double up on 15 because it's definitely the hardest. So take a pause, see if you can solve one of those. Okay, if you pause and should be checking, go ahead and make sure you've sort of shared with your group and see if they agree with you. So if you need to pause again, then do that, see what they think, if they agree. All right, let's check now. So 13, you should have had yes, it is congruent. We have those 90-degree angles, so we know those are congruent because they're the same. We have DC congruent to BC, and we also had a common side, so AC is congruent. So I have, now side angle is not a thing, remember, but there is hypotenuse leg. So I have our angles for right, so hypotenuse leg is only for 90-degree triangles. So I have the hypotenuse is the AC, it's the big one across from 90, and then we have this shared side as well. So I would say for my statement that triangle ADC is congruent to triangle ABC, and my reason is hypotenuse leg congruence. Okay, 14, another yes. In this case, you had to pick out the congruent, another set of congruent angles. So remember, always look and see first, like, are there any alternate interior angles? Those are only for parallel lines, remember. Are there vertical angles, etc. So here we had a vertical angle set right there. Oh, I need to put 2 lines because there's already an angle marked. So I have this set of angles congruent, those vertical in the middle, and then those lines. Okay, so I have angle, angle, side. One thing there is you don't want to say that opposite, like don't say side, angle, angle. It would be angle, angle, side. All right, so triangle XZQ is congruent to triangle, and I'm going to start with W because that's the one that was congruent to X. So W, Z, Y. Whoa. Straight line there. Okay, and our reason, again, angle, angle, side, not side, angle, angle. All right, last one, 15, and this was definitely the hardest. So I want to start off and look for congruence here. So they don't have any, right now there's not much marked. There's BC is congruent to CD. There's a start, but it's not enough to prove congruence. So I want to look for any vertical angles. Well, we have these middle ones here. So BCA is congruent to ECD. I could also mark these, but it really doesn't help me for my triangles. Okay, but do know that those are congruent. All right, still not enough. I have an angle and a side, so I want to see if there's anything else. Well, if these are parallel lines, so parallel there, this is my transversal, this line here, if you remember talking about that, hopefully. When we have that, our alternate interior, so inside the lines, and alternate sides of the transversal. So I have ABC here would be congruent to EDC. Okay, because they're alternate sides of transversal, but they're still inside these parallel lines. So really, these are parallel lines. They're just not showing that they like go on forever, okay? They can still be parallel though. All right, so now let's look and see if that's enough. So I have angle, side, angle. Well, yes, that's one of our statements, so that will work, okay? I'm gonna go ahead and highlight what these are. So that's alternate interior angles, which are congruent. And then here were our vertical angles. So that is enough for congruence, we said. So one last yes. And my statement would be triangle ABC is congruent to triangle EDC. And our reason is angle, side, angle congruence. All right, and that is all for today's. So, no, there's a lot of information. So if you have any questions, please be asking.